Hi, Aces 102. Welcome to the last installment of our crop production series. We're continuing on with the opportunities of crop production, which we left off on yesterday. As always, let us know if you have any questions. Either we can handle them for you, or of course, we'll pass them along to Dr. Pittelcow and see if he can't answer a few of these things for you. So let's jump in. Technical difficulties. There they are. So, where are we picking up from? Here on down. That's supposed to be an arrow. This way. So, we'll pick up from challenges in the developed world, our world. Big data, drones, various types of sensors. We'll define for ourselves what intensification means, because if we want to do more, we're probably going to want to do more with less. And we'll even outline a few pathways for engagement for folks like you. In the end, we still are thinking about and talking about closing yield gaps. We talked about new biology, but there is another way to do so, right? Increasing our management. And that's what we're probably referring to here. Data is a big part of it. That's what this figure here is intended to show. And there's loads of different data out there that are available for us as new opportunities. So what's the challenge? Management is already really pretty good, you might say. We've increased productivity since the Green Revolution at a tremendous rate. High yield varieties already exist. Many technologies are already being adopted. Okay, so how do we do even better? It starts to get even more site-specific. I sometimes call this hyper-local, managing a plant, individual plants rather than the whole field. We talk often about variable rate application of all the inputs that we use. So seed where it's most needed, fertilizer only where it's most needed, so on and so forth. But to be able to do so, we need the information in order to be able to know where we want to do this site-specific farming. So what are the sensors that are going to allow us to collect that information? And once we have those sensors in place, we're going to have a data problem in order to understand all that information and make it as useful as possible. It's not useful by itself. So we've been doing and experimenting with various forms of sensor-based nitrogen management. We can measure the reflectance off of a canopy utilizing various sensors to measure reflectance ranging from satellites to drones in order to understand where nitrogen is needed. And then, given that information, starting to consider where additional nitrogen could be applied. Irrigation, water is really the first nutrient, right? Knowing where and when and precisely how much water would be needed is always a function of weather, but if you can actually use a weather station like this one, you might be able to say, oh, we had plenty of irrigation, we actually had a shortfall in an instance like that, or we can start cutting back on our irrigation in a situation like this in order to avoid those overshoots and avoid those shortfalls. That comes from understanding what our plant needs and understanding how much water is in the environment available for those plants. You've heard of drones. There's new legislation out there all the time, it seems, describing where drones are allowed to be and how they're allowed to be used. So far, it does seem favorable for agricultural research and management of existing agricultural systems. So that does seem like a positive. And the idea being that you'll fly the drone over the field and you'll hang all sorts of sensors off of there. Visual cameras, for sure. You might already do this yourself. My son has several of these things. But you might also hang all sorts of other types of sensors off of there in order to see various ranges of the ultraviolet or the infrared spectrum or a number of other types of images. NDVI is one example of that. It's a vegetative index measuring really how much biomass is out there, and this is done by collecting what we call multispectral data which focuses on several key wavelengths of information, and we process that information by measuring the reflectance in each of those wave bands of reflectance across the spectrum. And this spectrum extends into the infrared ranges, so these are parts of the spectrum that our eyes cannot see, and produces a map that really effectively tells us how much biomass there is available in any given region. And again, you might be able to identify areas which need management. So what are the most typical applications that we've seen so far? You can go and scout your crop. You can monitor your equipment to make sure it's working properly. Hopefully you can potentially even identify weeds. The challenges start to become, and if you can do these things, you can then subsequently do variable rate processing. And it's worth mentioning, it's also useful for livestock farming. The challenge is, how close can you really get the sensors? Many of these sensors are various types of cameras. Resolution is an issue if you fly the drones too high. But also, getting them too close to the plant could endanger the plant. So that's a bit potential concern. And there's really no substitute at that point for you being next to the plant later. But it does present a challenge because now there's lots and lots of information. We already have electronic data regarding soils. If a farmer or a manager was interested in understanding what the state of nutrient was in his soil, there might be soil test data, and that might be associated with various points throughout the field. The farmer can record the data using his machinery to describe exactly how he chose to fertilize that field. So you even have a history of year upon year fertilization. We have yield maps that tell us the history of yield for those fields. We can understand the weather. We can map the weather. Disease history, so on and so forth. Anything you collected using the drone, that's another layer. And what you might begin to think upon, and that's is stack upon stack upon stack of many different types of data. All of which is probably indicative of something in the field, but individually by themselves are probably not indicative. It's not obvious, I should say, of what it's trying to tell the potential growth. So there's a challenge there to translate all that information into what I would call actionable information, something that you can actually make a decision on and take action for. That doesn't stop us, though. This is what data is about. You know that data is being utilized about you already on a regular basis. Why not in other domains too? And indeed, we do it in a number of different domains. You may have heard of Climate Corporation. This is a Monsanto company now. They were an independent company mostly studying and modeling weather. And they wanted to take that type of data in order to apply it to, well, finding what the best crop is, what's the best variety of any given crop within any given region. And you can see, you might remember a investment chart that I showed you, a venture capital investment chart that I showed you in the previous presentation. Look at what the price was to purchase Climate Corp for Monsanto. You can imagine they're expecting a big turnaround from that type of business. The Farmer Business Network is yet another company that's out there, which also has a fairly interesting amount of press. They sell membership to farmers in order to leverage data that's collected from other farmers that are part of their network in order to provide site-specific information on how to farm. This is another big investment company. You might have recognized the company that was recently in the press investing in farmer business, the Farmer Business Network. Google is behind them, so you can imagine that's it's an undisclosed amount of money, but a considerably large one. This is a local company here, Agrable. If you get a chance to hear Chris Harbord speak about this particular business, I'm sure you'll be quite impressed. They have a number of different products. Their angle on the business is to, again, collect farmer information. They're actually paying the farmer to provide the data, and then they subsequently are working with supply chain partners in order to make the supply chain itself more sustainable in a number of different ways. It may come as a surprise to some of you, but a number of different companies out there are very interested in certifying that their supply chains are sustainable or are increasing in sustainability. Notably, Walmart, PepsiCo, Kellogg's, so on and so forth. A number of different companies are out there that are very interested in making their businesses quite sustainable. Uh, What is sustainable intensification now, right? So we have data. We have data that may allow us to manage our farms better with the underlying goal of course, increasing yields, increasing productivity. But as this chart on the left suggests, as yield goes up, we have a supporting relationship that suggests environmental impact will also go up. Is it possible, especially if we manage things better, is it possible to turn that relationship around, to make environmental impact decrease with increasing yields, to create an opposing relationship? That's what sustainable intensification would intend to be. Okay, it's pretty broad-reaching, right? We want to increase yield, probably providing increasing income for those that are working in those areas, make it attractive for them. But at the same time, improve their health, improve their livelihood, improve the health of the folks that are consuming all these goods, equalizing that social equity across these things. So on the right is a chart you'll see from CIGAR. Is an international organization working with the United Nations and the FAO in order to provide developing world opportunities, and they list a number of different factors. That's what this sort of star shape is, where they go and list their factors. And there's numerous ones because they're both related to development as well as the environment as well as food security. And the question is can we have it all, right? The question starts to become then, how do we get there? Are there specific practices we should be supporting? Are there thresholds that prevent or support sustainability? How do we compare different types of systems in order to be able to provide recommendations as to which ones are better? How do we prioritize specific targets across the spectrum? So, for example, there are some studies out there. Let me know if you're looking for them. What you have across the horizontal here are different crops. On the vertical here is the energy use for different sectors that provide us that crop. And that's what the different shades and cross-hatching are regarding. So for a barley crop, down here, oops, let me clear that. There, you need nitrogen, you need potassium, you need phosphorus, you need lime, all to produce barley. You know barley, right? Herbicides, pesticides, transport of the inputs. You need on-farm energy. That's what this little bar is about. In order to, and that all accumulates into a total energy consumption for that particular crop. And what this paper does a nice job of is present us the energy consumptions for all those different aspects of the food system. Grains, here's maize or corn, one of our favorites, right? Has a big energy consumption for on-farm fuel use and all the nitrogen. It's a very extractive crop. Many of those grains are, for all the nutrient it needed in order to be able to support itself. Okay, the oil seeds, soybean in particular, the legume, is here. Oops, sorry, it's over here. And you can see that there's no nitrogen bar there. It's a fixing crop that can handle its own nitrogen requirements. So interesting stuff, right? What if we could turn some of these things on their heads in order to avoid energy input, particularly for nitrogen fertilization? Yeah, that would be a great outcome, and that would support intensification. Okay. Carbon footprints certainly are of a big concern. That's effectively what all that energy consumption amounts to. Once you've consumed all that energy, you needed fuel, you impacted the environment by off-gassing CO2. Here's the footprint of farming. And within that footprint, you can see energy supply again, transportation again, across a number of different portions of our food and agriculture system, and the supporting industries of that food and agriculture system. Okay, where does the carbon go? Much of it on the energy side does go into the atmosphere, but let's not forget, we talked about it previously, some of it actually does end up in the soil too. It can get returned from the soil in some instances, depending on the environment and the type of crop rotation. You can actually put down quite a lot of carbon into the soil, indeed offsetting what was put up on top. So it's not a free lunch in every case, but there are some situations which are particularly attractive. So that leads to forms like this one, put out by the French Ministry of Agriculture to help provide growers with plans that might help them get to food security, of course, but also offsetting or eliminating the amount of carbon that's being put up into the atmosphere. Okay? How do you do that, though? If you're the grower and you're in the situation where it becomes your responsibility to certify these things, you need to have a tool to help you do so. Indeed, there are parts of the world, particularly in the EU, where this is a major business, auditing and providing that calculation of your footprints. This is a new one that's even applied in the US called Field Print. Go and look it up. It helps you understand some of the basic efficiencies of standard practices, and then starts to help you compare and contrast some alternative programs. And it's constantly under development. Okay? You can get the feel, however, though, when you think about all of the potential different factors, how do you manage them all? There's so many different objectives now. This is a view of a similar program used in Argentina, where each of these little dials is representing a different, it's in Spanish, mind you, so take some time with it, a different factor that may be of importance when it comes to either the impact on the environment or the efficiency of that particular system. This is your nitrogen balance up here, phosphorus balance, carbon stocks in soils, carbon stock in the biomass, and so on and so forth. I happen to be able to read Spanish. So you can go around that circle and you begin to realize that quite rapidly the system becomes very complex, because there's indeed so many different ways to measure its performance and its quality. Can we have it all? Could we really hit all those different marks? You might have to begin to realize that you might potentially set yourself a goal for every single one of these different dials. Maybe that's too much. Maybe some of these are more important than others. That's actually something for you guys to be deciding. So not all indicators are as important as you mean, and some of them do interrelate with one another, which confounds things. And then there are barriers to collecting and certifying the quality of information for any given system. So it's not as easy as looking on the surface of the system to gauge its productivity, for example. The long-term goal is to make some sort of an evolution, reduce the impact of our current systems, become more efficient, avoid inputs where they aren't necessary, effectively redesigning these systems to make the systems more at harmony with their landscape, without sacrificing productivity, right? Or cost, or impact, and equity. It's not an easy problem. So don't forget that. We talked about this. This is a repeat slide again. The current benefits of current conventional agriculture are real. They are real. Economies of scale for large farms make your food cheaper. Bottom line. And that's because there's less labor required, and you can and because of that, you're even with less labor, you are still having high yields. You're feeding many people, and you're actually making a very attractive economic opportunity for those people working in those systems. The bottom point here about the short-term horizons of our economic systems, they do have impact, right? So farming is done on a year-to-year basis. Every year I plant, every year I harvest. That's my payday, the harvest day. But until then, I've only spent money on inputs. So you have to focus on this year in order to make this year profitable. If you make changes in your system, probably you can't sacrifice this year, or else it may be, in fact, difficult to even start farming next year. And that's a real challenge, not one that we can ignore too easily. And because of that, it puts a lot of pressure on us to do everything above, maximize your labor and cost efficiency in order to keep the current system up and running. Changing it is a big risk. So, to change that, you've got to be able to manage more time, more labor, and be smart about it. Be able to wield the knowledge when and where it's necessary. And that's often more expensive right now. It's not easy to improve upon that. Not that we're not trying, but it's not easy. Okay? So if you want to get involved, it's about getting you out there to do it, getting you out and farming yourself. There are ways to do it. ATRA is a great resource available out there for you with lots, and when I say lots, an incredible amount of advice for folks like you who might be interested in learning more. I'd suggest you go and look it up. And the image on the left comes from the website Worldwide Opportunities on Organic Farms. That might be of interest for some of you, because it's not easy, and we need people to know how. You can even do a little bit of that on campus. Sustainable Student Farm is just south of Windsor Road down Lincoln. I'd urge you very soon this year, if they're probably already started in some of their hoop houses in order to extend their growing season. You could probably get some information and some experience. Of course, we have crop sciences on our campus. You know that Dr. Pittelcow is from there. There's a number of different concentrations that are all related to the things that we've discussed that would allow you to go deeper if any of you are interested, and a number of different courses. Dr. Pittelcow teaches here. Crop Sciences 112 is one of his main courses. Maybe some of you know him already. There's a couple of minors that allow you to dip your toe in, and I think would be really quite relevant to a number of the things that we discussed. And finally, if I'm not mistaken, this is our last slide. There's also a minor in sustainability that might be of interest for you, and there's even a fellowship program for those of you who might be interested in some of these topics. These are slides from 2016, mind you, but if you're interested, do let us know, and we'll see if we can try to connect you with those people. As always, any questions, let us know, and we'll do the best we can to help you. I hope you've enjoyed these videos. I can't turn it off. There we go.